For this problem, again, we get infinity over infinity. We divide by the highest power of x. We are now going to get the limit as x approaches infinity. This is 2 divided by the square root of x plus the square root of x divided by the square root of x divided by 2 divided by the square root of x minus the square root of x divided by the square root of x. So this is the limit as x approaches infinity of 2 over the square root of x plus 1 divided by 2 over the square root of x minus 1. This term having x in the denominator will go to 0, as will this term. So we get 1 over negative 1. So this answer is negative 1. Let's look at something very similar but slightly different. We now want to look at the limit as x approaches infinity of the square root of x squared plus 2x divided by 2x minus 3. So we want to, again, divide by the highest power of x, but we can see that in the numerator, we have x squared plus 2x. So one would think that you would divide by x squared, but x squared is inside the numerator. So if we treat it as if this 2x were not there, that also gives us an x. So we're going to get first our usual infinity over infinity. That is our indeterminate form, which tells us we need to work harder. So when we divide by the highest power of x, we get the limit as x approaches infinity. I'm going to divide the numerator by x, so that looks like 1 over x times the square root of x squared plus 2. And then I'm going to get 2x over x minus 3 over x. So when I put 1 over x inside the square root, I'm now going to get x squared over x squared plus 2 over x squared inside the square root all over 2 minus 3x. And I forgot my limit, so let's rewrite this as the limit as x approaches infinity. Pushing it through, we're going to get x squared divided by x squared plus 2 over x squared. That's in the square root divided by 2 minus 3 over x. So in the numerator, I'm going to get, let me just, x approaches infinity. I'm going to get 1 plus 2 over x squared. That's still inside the square root. And as we said in the denominator, we get 2 minus 3 over x. So now we can see as we push the limit, 2 over x squared goes to 0. 3 over x goes to 0. This answer is 1/2. So now we want to look at the limit as x approaches 8 from the left of 2x over x minus 8. Now we can clearly see by direct substitution that we get 16 over 0. So that's some form of infinity. We know that's either plus or minus infinity, but we need to be precise in our answer. So as we're looking at this, the values that we are looking at, because we have 8 negative, not negative 8, but 8 from the left, these numbers are a little bit smaller than 8. So since those numbers are a little bit smaller than 8, then this 8 minus 8 is a little bit smaller than 0. So technically, this is a little bit smaller than 0, and something a little bit smaller than 0 is negative. So we can now say this answer is negative infinity. And the limit as x approaches an 8 from the right of 2x over x minus 8, again, is going to give us 16 over 0. However, the numbers that we are looking at, we're approaching 8 from the right, so they're a little bit larger than 8. So that means this number is a little bit larger than 0. So this will give us positive infinity. Let's look at a limit that results in another indeterminate form. So we have the limit as x approaches infinity of the square root of x plus 9 minus the square root of x plus 4. So direct substitution, this first term goes to infinity, and then the second term goes to infinity. And because one infinity minus another infinity is not 0, we cannot make that conclusion. So this, we know that infinity minus infinity is not 0. So therefore, we need to work a little bit harder on this problem. In order to do that, we have the limit as x approaches infinity. I'm going to take this quantity, the square root of x plus 9, minus the square root of x plus 4. And I'm going to multiply it by the square root of x plus 9 plus the square root of x plus 4 divided by the square root of x plus 9 plus the square root of x plus 4. Now I can do that because the value of this is just equal to 1. So I can multiply any equation by 1 and remain its integrity. So now I'm going to get the limit as x approaches infinity in the numerator. We're going to FOIL that. or we're going to use the distributive property twice, depending upon what you have learned. So we're going to get the square root of x plus 9 times the square root of x plus 9. So that's just going to give us x plus 9. And then we're going to get the square root of x plus 4 times the square root of x plus 4. So that's going to give us x plus 4. And then we also know that the middle terms are going to add and subtract each other to give us a 0. And then in the denominator, we're going to get the square root of x plus 9 plus the square root of x plus 4. So now we get the limit as x approaches infinity. So now x and negative x are going to add to 0. And 9 plus 4 is going to be 13 all over the square root of x plus 9 plus the square root of x plus 4. So we have, when we take this limit, we have 13 over something that is virtually going to infinity. So we're going to write that solution. That means that the limit as x approaches infinity of the square root of x plus 9 minus the square root of x plus 4 is indeed 0.